Okay, so let me first discuss with you elimination reactions. So for elimination reactions, uh, our substrate is typically an alkyl group with a leaving group. But aside from this, there should be beta hydrogens. No? So by beta hydrogens, we are referring to this hydrogen right over here. If this is your alpha carbon, wherein you have your substituent, then the adjacent carbon, whether on this side or on the other side, that will be the beta carbon. And the hydrogens attached to the beta carbon will be beta hydrogens. So this is an important requirement in elimination reactions. Okay. The reason being, in elimination reactions, your attacking agent is a nucleophile. However, this nucleophile is acting as a base. I'm sorry. So our nucleophile is acting as a base, and therefore it will attack an acidic hydrogen. So this beta hydrogen is the acidic proton. Okay, so this is simply an acid-base reaction. So the base will abstract the proton, and this bonding pair will be part of the carbon-carbon double bond, forming your alkene group, no, or your carbon-carbon double bond. No? So ganun ang nangyayari. Okay, so also take note that elimination reactions compete with substitution reactions. Okay, so sometimes depending on the condition of the reaction, it can either undergo SN1 or SN2 or E1, E2. Okay? So yung substitution natin, if you recall, you can have SN1 or SN2, and therefore an elimination reaction can compete with these two reactions. Elimination 1, E1 will compete with SN1. E2 can compete with SN2 reaction. Okay? Now, one good example of this is the use of alkoxides as the attacking agent. So the alkoxide will act as a strong base, and therefore it will favor elimination reactions over substitution reactions. Okay. So a good example of this will be dehydrohalogenation of alkyl halides. And this is typically used for the synthesis of alkenes. So for example, you have these two bromopropane, and you react this with sodium ethoxide. So again, the ethoxide group here will act as a base. Yeah. So this is your base, this is the attacking agent, and it will abstract a proton. No, yung beta hydrogen, saan yung beta hydrogen natin? It can be this hydrogen or that hydrogen. Kasi ito yung alpha natin. No? So it can abstract this proton here or there, producing your alkene group. So the same is true for this tertiary butyl bromide. Again, you have your sodium ethoxide acting as the base. It can abstract any of the beta hydrogens. So it can abstract hydrogens here, there, or this set of hydrogens, producing your alkene compound. So that is hydrohalogenation. We are removing a hydrogen and a halogen. Elimination reaction. Okay, now how do you produce an alkoxide base? So the alkoxide, or in this case, you have ethoxide. So the sodium ethoxide can be produced from the reaction of ethanol with sodium metal. Okay. So in this case, the hydrogen can be abstracted by sodium, no, and then you form your sodium ethoxide dissolved in ethanol. That's why usually you'll see this reaction condition. So meron tayong sodium ethoxide, and this is dissolved in ethanol. Okay, or we can have a reaction between an alcohol and sodium hydride. So remember, the hydride is acting as the base. The alcohol will act as the acid. Okay, so when this base reacts with the acid, you form hydrogen gas. You'll see bubbles forming in the solution, and you have dissolved sodium ethoxide in alcohol. Okay, so for example, you have tertiary butyl alcohol. You can react this with sodium hydride or potassium or sodium metal. You produce potassium or sodium tertiary butoxide plus hydrogen gas. Okay, now as I mentioned, you can have E1 or E2, elimination unimolecular, and elimination bimolecular. So let's start with E2. So this is similar in terms of mechanism to SN2. Okay. So ang note ko dito, guys, is that this reaction competes with SN2 reactions. And therefore, it follows a similar mechanism to SN2. So ano yung mga similar features niya? So E2 reactions also involve a concerted process, just like your SN2. But instead of nucleophilic attack, no, there will be removal of the proton. And at the same time, formation of the double bond. So this is a one-step reaction wherein the transition state will have proton abstraction, formation of the double bond, and at the same time, removal of the leaving group, okay, or departure of the leaving. Okay. Now, both the alkyl halide and the base will have an effect on the rate of the reaction. No? Kaya siya second order reaction. Okay? So ito yung pinaka-mechanism niya, forming your alkene. Okay. Oops, sorry. Okay. So that is for E2. Now for E1, this typically competes with SN1 reactions. And just like SN1, it goes through a carbocation intermediate. So the first step of the reaction is the formation of a carbocation. Okay? So ito siya, no? So let's say you have a tertiary butyl chloride. You first remove the leaving group, forming your carbocation plus the chloride. And then this is followed by hydrogen abstraction. Again, it's the beta hydrogen that will be removed, no, by a base. No? So pwedeng water na siya. No? So this water will act as the base. This hydrogen will act as the acidic proton. Okay? And this bond will now form a double bond with carbon, forming your alkene. And of course, hydrogen ion. Okay, so that will be for E1. Okay, so pwedeng it will undergo SN1 or it can undergo elimination reaction, depending, of course, on the conditions, no, of the reaction. Okay, so SN2 and E2 are competing reactions. So your nucleophile can act as a base, so it will abstract the proton, or it will act as a nucleophile that will attack your partial positive carbon. So kapag high proton abstraction, that will lead to elimination. Pero kung nucleophilic attack, that will lead to substitution. Now, when will it favor elimination reactions, and when will it favor substitution reactions? So let's look at SN2 versus E2. If you have a primary substrate, no? So if the base is small, then SN2 competes strongly versus your E2. No? So dominant ang SN2 versus E2 because your carbon is unhindered. Remember, for SN2, it is important that the carbon, the partial positive carbon, is unhindered, less steric effect. Okay? So in this case, if you recall what will happen, itong oxygen natin, oops, sorry. Just go back there. Okay. So what happens here, again, kapag SN2 reaction, di ba, backside attack, it will attack this carbon, and then this bromine will be the leaving group, leading to an SN2 product, which is an ether, no, magiging diethyl ether. However, it's also possible that you can have elimination reaction. So this will act as a nucleophile, forming the substitution reaction, no? Or it can act as a base, removing this proton. So kung base siya, itong tatanggalin together with the leaving group, forming your ethene compound. Okay? So again, if you have a primary substrate and the base is actually small, SN2 predominates over E2. Now, if you have a secondary substrate, so secondary to, di ba? Bromine is attached to a secondary carbon. The approach to the carbon is already sterically hindered, and therefore E2 is favored. Okay? So again, there are two possible points of attack. Your oxygen can act as a nucleophile. Kung nucleophile siya, diba dyan? So backside attack is a nucleophile removing the bromine. And you form your ether. Or this attacking agent, yung ating ethoxide, will act as a base, removing this proton, and forming your alkene compound. Okay, so for a secondary substrate, no, this time elimination is favored over substitution because your carbon is, this carbon is already sterically hindered. Okay, for tertiary substrate, the approach to the carbon is extremely hindered and therefore elimination predominates, especially at very high temperatures. No? So again, you have two possible. Remember, since this is already tertiary, so it will undergo SN1 type of reaction. Okay, so ito yung SN1. So when it undergoes SN1 reaction, so you'll only have 9%, but it's also possible to have an elimination product. Okay. Dito, lumalabas siya daw ay mainly E2. Bakit E2? Kasi, oops, well, nandito naman kasi ang ito. It's not sterically hindered, this probe. Kaya pwede naman siya matanggal together with this probe. So elimination ang major product. Now, at much higher temperatures, may mali dito. Hindi, okay. So, in this case, bakit naging 100% E2 plus E1 and then you have your alcohol? Well, what happens here is parang may mali dito sa aking reaction. But anyway, I think yung attacking agent is different. So anyway, again, it favors elimination reaction versus substitution. So ang nangyari dito ay again, hydrogen abstraction or proton abstraction is favored, removing this. Okay. Now, pwede rin kasi bakit naging ganito, paano nabuo to? This alcohol. Because remember, the first step of the reaction is a carbocation. Diba? Ang unang mangyayari, you have your carbocation. Let me just draw that. Para mapakita lang yung formation nitong alcohol. Ayan. Diba? So that is the first step. No, removal of the leaving group. You form the carbocation, and then this will act as a base. Abstract that. Magiging ganun. Okay. Forming your alkene compound, and then this will be the alcohol. Kaya nagkaroon kayo ng alcohol. Kasi this is acting as it will abstract this proton. So alcohol ang product. Okay. So 100%. Okay, so another case, so again, temperature, increasing the temperature favors elimination over substitution. Next factor will be the size of the base or nucleophile. So large sterically hindered bases will favor elimination rather than substitution. No? Uh, so here is an example wherein you have a primary alkyl halide. Balikan ko lang to. Di ba ito rin primary alkyl halide din to. But take note that the base is small. Okay? So it will favor substitution. Now, in this case, you also have an alkyl halide, primary alkyl halide, but this time your base is large. The nucleophile is quite large. So you have steric effect. No? So it's difficult to attack this carbon due to steric effect. So it's better that it will undergo elimination. Kaya favored itong elimination over the substitution. Yeah. Okay, now let's talk about stereochemistry, no? Especially of elimination reactions E2. Okay, so the beta hydrogen and the leaving group should be periplanar. No? Ibig sabihin, magkatapat sila. No? So it can be anti or syn. Okay, so when we say periplanar, they should lie on the same plane. Okay, with respect to your single bond. So pwedeng anti-periplanar, meaning it will assume an anti-conformation. Okay, recall your isomerism. Di ba meron kayong anti-conformation and eclipse conformation. So kapag anti-periplanar, anti-conformation. Syn-periplanar, it's in the eclipse conformation. So this is anti-periplanar. Diba? We're looking at the hydrogen and the leaving group. Anti ang position nila. Versus this one, this is eclipse. Diba? Yung leaving group mo is eclipsing this hydrogen. Okay? Or ayan, something like this. Diba? Eclipse versus anti. Okay? Now, what happens here is once the beta hydrogen and the leaving group are removed, the p orbitals are aligned so that these p orbitals can overlap each other, forming your double bond. Kaya nagiging double bond sila. Okay? So halimbawa ito. So this is anti-periplanar. We remove the proton. We remove the leaving group. Okay? You form p orbitals. And then these two p orbitals will now overlap with each other, forming the pi bond. Or it's also possible we remove this proton and the leaving group, you form also this set of p orbitals that are periplanar or aligned with each other. Okay? So you can have anti-elimination or syn elimination. Anti-elimination or syn. Okay? Now, the type of elimination reaction will lead us to a certain stereoisomer. Okay, so for example, here, kung anti-elimination, we are going to remove this proton and this leaving group. Tama? Forming a trans or E isomer. But for a syn elimination, we are removing this proton and this leaving group. So you will produce a cis or Z isomer. Zinzide, di ba? No? Kaya Z isomer. Okay, now usually guys, a reaction will undergo anti-elimination. Okay, now in some cases, if the molecule is quite rigid, then it will preventing anti-elimination, then it will favor syn elimination. Okay, so here is a good example, no, to illustrate that. Kasi sabi natin, anti-elimination is typical. Okay? So, kung anti-elimination siya, ano sabi natin? We are going to remove dapat itong hydrogen, this proton, and this leaving group. Diba? Kung siya ay anti-elimination. But if you look at the way it is drawn, they are not periplanar to each other. No? Kaya nga, this will be difficult to form. Kasi ito is oriented this way, tapos ito, pag ganon. So, in other words, if you're going to draw the Newman projection, i-Newman natin, Newman projection siya. It is something like, ano ba natin in-Newman? Something like this, pag ganon, then pag ganyan. So, hydrogen is here. Okay? But if we draw this portion, yung back carbon, the tosyl group is here. Oh, hindi sila periplanar. Okay? They're not periplanar. Kasi ang periplanar, di ba, dapat ganito. Kung anti, di ba dapat ganyan? Eh hindi. Hindi sila periplanar with each other. So, we cannot form this. However, we can have syn elimination. So sa syn elimination, we are going to draw the Newman projection. No? So parang ganito siya. Okay. So you have deuterium here. Diba? Tapos hydrogen. And then this is carbon. Tapos you have something like this. This is your tosylate. We are removing this deuterium and the O-tosyl group. Oh, then they are syn periplanar. Which is the requirement. Because they are periplanar, then it will undergo syn elimination. Okay, and this is non-periplanar. Okay, so it will not undergo anti-elimination. So yun yung sinasabi dito. Having a rigid structure. Okay. Now, what about regiochemistry? Okay. Kasi ito ang diniscuss natin, yung stereochemistry. Okay. So, anti versus syn elimination. Now, let's talk about regiochemistry. Which beta hydrogen will be removed? Okay. So, if we consider this reaction, elimination of 2-bromobutane, two possible products are formed, this or this. So, bakit? You have to types of beta hydrogens. Diba? You have a beta hydrogen here or a beta hydrogen there. So pareho silang beta. Kasi ito yung alpha mo. Diba? So we can remove this proton, or we can remove this proton. Teka, parang mali yung direction ng arrow mo. So we can remove that proton or we remove that, producing this. Now, as you can see, you have 80% for an internal alkene versus 20% for an external alkene, meaning the double bond is internal within the inside the molecular structure, and this is towards the outside. Yung terminal pala, terminal, no, na alkene. Okay? So ibig sabihin, if this is 80%, we remove this proton. Okay? So why is beta carbon with less hydrogens attacked more? No? So ito yung beta hydrogen with less, beta carbon with less hydrogen. So that, as you can see here, you will form a more stable, alkene. And how do you stabilize an alkene? Sige nga, kindly recall. How do you stabilize an alkene? What makes it more stable? Yung internal alkene versus a terminal alkene. Okay, you can have CH hyperconjugation. Diba? So that can help stabilize your alkene. Kaya itong proton na to ang natatanggal to form the double bond as compared to this. Right? So it has something to do with that kind of stability. Oops, sorry, hindi nabura. Okay, and again, we follow a certain rule known as Zaitsev. Okay, so according to Zaitsev's rule, the more stable alkene is being formed, meaning the alkene formed is the one that corresponds to the removal of the hydrogen from the beta carbon having few hydrogen substitute. Okay, so ito yun. So most E2 reactions will follow Zaitsev's rule. Now, there are cases. Basta ito yung isipin nyo. Laging Zaitsev siya. Now, there are of course exceptions to the rule. No? So there are cases wherein it will follow what we call a Hoffman elimination. Okay? So dalawa po yun. Zaitsev elimination versus a Hoffman elimination. Kapag sinabi natin Hoffman, edi yung less stable alkene. So if we go back to this one, this is your Zaitsev. Okay. And this will be Hoffman elimination product. So majority, again, typical, it will follow the Zaitsev rule, but there are cases wherein you can have Hoffman elimination. Okay, so what are those cases? Ito na yung titignan natin. Okay, number one, when the leaving group is either a chlorine, no, or an ammonium group, or you have a sulfide group. Bakit silang tatlo? Because these are strongly electron withdrawing groups. Okay. So, for example, here you have an alkyl ammonium group, and that has a great effect on the acidity of the protons. Lalabas ngayon, this proton is more acidic than this one. At dahil acid-base ang reaction natin, again, your alkoxide is a base, so it will attack the most acidic proton, which is this one. Okay, leading to a Hofmann elimination product. Okay, another case will be brought about by steric effect. Okay, so ito. Kung halimbawa, dalawang klase, di ba? You have this proton here. You can have this proton. Okay, or, so ito ay alpha, beta, beta. So meron pa tayong isang proton dito. Diyan. Okay. Kung side-Ceph elimination ang gagawin natin, then we are removing this proton. This will form the double bond. That will be side-Ceph. However, remember this base will have to abstract this proton. And this is hindered due to the presence of these two alkyl groups, two methyl groups. So this is sterically hindered. This proton, itong proton, is more accessible. So, dito na lang. Ito na lang. Forming the Hofmann elimination product. Okay, so these are the two cases that you need to remember. Okay? Leading to the Hofmann elimination.